Hello, in this video we're looking at section 9.3, trig functions of an angle, day 1. Okay, so our learning target for this video, at the end of this video, you will be able to evaluate trig functions of any angle. In our next video, we will find and use reference angles to evaluate trig functions. So the core concept over here, we can see that we have this angle theta, and it's an angle that's in standard position. Right? So here's its initial side, here's its terminal side, and this point xy is the point on the terminal side where theta intersects this circle that's x squared plus y squared equals r squared. And so if we think of the 6 trig functions that are associated with the angle theta, well, the sine function is going to be y divided by r. So it's this y value, this point that's on the terminal side of the angle. It's a y value for that point divided by the radius for the circle. Cosine is going to be x divided by r. And then tangent is going to be y divided by x. In this case, there's a restriction on the domain, so x cannot equal 0, because if we think about it, x in the denominator here can't be 0. It'll be undefined. Okay, for cosecant, it's going to be the ratio of r divided by y. Again, the denominator can't be 0, so we're putting the restriction there. Secant of theta is r divided by x, where x cannot be 0, and cotangent will be the ratio of x over y, and y cannot equal 0. So these functions are sometimes referred to as circular functions. All right, let's look at our first example here. We're going to evaluate our trig functions for a given point. So our point is 8, -6, and this is a point on the terminal side of angle theta. In the standard position, we're going to evaluate the 6 trig functions for theta. So notice 8, -6. So ask yourself, what quadrant is this in? And hopefully you said it's in quadrant 4. So we're going 8 and then -6. So this is the point on the terminal side of that angle. And so the angle actually goes to here like this. There it is. Okay, so that's our angle, and we're going to label that as theta. This is actually a circle, so if you can imagine there's a circle that's going around like this, and this is the point on that circle. So let's label this point. It's 8, -6. Now the missing piece, or the piece that we don't know, is r. So what's the radius of the circle? So we could think, well, we could draw a triangle here, and we know the length of this side of the triangle is our x distance, so, or x value, it's 8. And then over here, we're going down 6 units, so although the distance can't be negative, I'm still going to label this as a -6. And so then I'm just going to use the Pythagorean theorem to figure out what r is, because this is a right angle here. So r squared is going to be equal to 8 squared plus -6 squared. So we end up with r is equal to the square root of 64 plus 36. So it works out real nicely for us. R is equal to the square root of 100, so r is equal to 10. So the radius is just going to be 10 here. All right, so we're going to evaluate our 6 trig functions for theta next, but before we do that, I want to label out what I know. So we know that x is equivalent to 8, we know our y is equal to a -6, and we know r is equal to 10. Okay, so now I'm ready to find all 6 of my trig functions. So the sine of theta, we said it's going to be the ratio of y over r. So this is going to be equal to -6 over 10. So we need to make sure we simplify this. So this is -3 over 5. Okay, let's look at the cosine for theta. So we said that this is going to be x over r. It's the ratio. And this is 8 over 10. So we're going to simplify this to 4 over 5. And tangent of theta, we said, is going to be the ratio of y over x as long as x is not equal to 0. And in this case, we see x is 8, so it's not equal to 0. So we get a negative 6 over 8, which simplifies to negative 3 over 4. Okay, now we're ready to find our cosecant for theta, which is really 1 over sine, or it's r over y, so it's 10 over negative 6, or 5 over negative 3. And then we're ready to find secant of theta. So again, it's 1 over cosine of theta. So this is going to be the reciprocal of the cosine, which is 5 over 4. And then lastly, cotangent of theta is 1 over tangent of theta. So it's going to be the reciprocal, so we end up with negative 4 over 3. So there's our 6 trig functions. Okay, in our previous example, we looked at a circle where the first step was we had to find the radius. We had a point on the circle, and then we had to find the radius, and then we were able to evaluate the 6 trig functions. Right now we're looking at this idea of the unit circle, and the unit circle is a special circle because it has a radius of 1. It's centered at 0, 0, and all the way around the circle the radius is 1. So what does that do for us? Well, it really simplifies your trig ratios. So let's think about it. Before we said the sine of theta is equal to y over r. Well, when you have a unit circle, the radius is 1, so your sine function, the sine of the angle, is equal to y over 1, so it's just equal to y. So whatever your point is on the terminal side of the angle, the y value is sine, and then your x value is going to be your cosine value. Okay, let's look at example 2 here, where we're using the unit circle to evaluate 6 trig functions for the angle theta that's going to measure at 90 degrees. So take a minute and visualize, where is this angle 90 degrees? Well, hopefully you're saying it's this angle right here. Theta is equal to 90 degrees right here. So this is the terminal side to the angle. This is actually a special angle. It's one of the quadrantal angles, so each of the quadrants has on its terminal side for the angle will stop at the end of one of the quadrants. So for example, this quadrant 1 here stops at 90 degrees. Quadrant 2 stops at 180 degrees. The next quadrantal angle is 270 degrees, and then the next one is 360 degrees. Since this is a unit circle, we know the radius of this circle is equal to 1, so we could write that. Let's label that here. Radius is equal to 1. The point right here on this circle, if we wanted to label our x and y, x value 0, and our y value is going to be 1. So we could actually label this too. X is equal to 0, y is equal to 1. Okay? So let's look at the sine of theta, which is 90 degrees in this case. So sine of 90 degrees is just going to be y over r. So in this case, it's just y, because r is equal to 1, so we end up with 1. Cosine of 90 degrees is going to be equal to x over r. Cosine is just going to be 0. And the tangent of 90 degrees is going to be equal to the ratio of y over x. So we know this is equal to 1 over 0. Notice this tangent of 90 degrees is undefined. Okay, it's going to be undefined. All right, moving on. Let's look at the cosecant of 90 degrees, which is 1 over the sine of 90 degrees. So it's just going to be 1 over 1, so it's just 1. The secant of 90 degrees is going to be 1 over 0, because remember this cosine is x over r. So this is 0 over 1, so this would be 1 over 0. So the secant, 1 over 0, this is undefined. Secant of 90 degrees is going to be undefined. And then the cotangent of 90 degrees, Well, we can see it's the reciprocal. It's x over y, so it's going to be equal to 0 over 1, which is equal to 0.